Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 1 video on the next chapter of parallelograms, where I will discuss the basic concepts of what are parallelograms and the properties of parallelograms with few illustrative examples of parallelograms, and I will not solve any problems in this video. This will be purely theoretical video uh, on the geometrical properties of parallelograms. In the next video, I will try to prove the properties of parallelograms and solve few fundamental problems on the properties of parallelograms. So this video is part of the playlist CBSE Maths 8 RS Aggarwal, where I strictly follow the concepts and formulas given in the textbook of RS Aggarwal and solve all the exercise problems. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future video. So let's get started with the part 1 video on the chapter of parallelograms. Okay, so I have prepared the rough notes about the parallelograms and its properties that I will discuss in this video. This video will not be that long. I will try to make it short. Okay, so let's get started. So previously, just before this, I have completed the chapter of quadrilaterals, and before that, I have completed the chapter of polygons. It is highly recommended and suggested and advised that you should have a good concept about the polygons and the quadrilaterals, because a parallelogram is purely based on quadrilaterals and the polygons and their properties. Okay, so what is a parallelogram? Parallelogram is a quadrilateral whose both pair of opposite sides are parallel. So we know that in a quadrilateral we have quadrilateral is a polygon of 4 sides, and that is pretty much about what a quadrilateral is. It is a in this class, I think mostly we will deal with, there are two types of polygons, concave and convex. Quadrilateral can also be concave and convex, but mostly we will deal with convex quadrilateral, that is convex polygon having 4 sides. Okay, so a parallelogram is a quadrilateral whose both pair of opposite sides are parallel. We have already covered the concept of pair of opposite sides and angles in a quadrilateral. Okay, so let's try to understand. I have drawn few figures. Let's try to see which of these figures are parallelogram based on the condition that both pair of opposite sides are parallel. Now, to indicate that which opposite sides are parallel are parallel and which are not, I have tried to visually indicate that using some of the dotted lines. Let's consider this be figure 1, quadrilateral 1. As you can see, the quadrilateral is ABCD. Okay, now clearly we know that the opposite sides are, in short, I am writing OS as the opposite sides. The opposite sides are AB, and there are 2 pairs of opposite sides in a quadrilateral. So in this quadrilateral ABCD, the one pair of opposite sides is AB and DC. The other pair of opposite sides is AD and BC. We need to check whether these 2 pair of opposite sides are parallel or not. Now clearly the dotted lines says that the pair of opposite sides AD and BC, when they are extended, they are meeting at the point E. So definitely AD and BC are not parallel. The opposite sides AD, I can say that AB, these two are opposite pair of opposite sides in this quadrilateral. Now, if they were parallel, I would have said this is the symbol of parallel. Now, I am using my own convention. I don't know whether this is a recommended convention or not, to indicate, to say mathematically, to say that AB is not parallel to DC. I am using this striked away parallel symbol. So this means that AB is not parallel to DC. Please do not consider this symbol as a standard symbol. I don't know. This is I am using this symbol. This is my convention, just for the sake of discussion. So we can clearly see AB is not parallel to DC. Similarly, if you see when the sides AB, when the other pair of opposite sides AB and DC are extended, they are meeting at the point F. So definitely, I'm so okay. So AB and DC, AB is not parallel to DC. Okay, fine. Now we need to check whether the other pair of sides AD and BC is parallel or not. Now we see that when the sides AD and BC are extended, they are meeting at the point E. So clearly AD is also not parallel to BC, because if two straight lines intersect at a point, they are not parallel. Two parallel straight lines never intersect at a point. So clearly we can see that in this quadrilateral number 1, none of the pair of opposite sides are parallel. So this is not a quadrilateral. By cross marks by X, I am saying this is not a parallelogram. Okay, let's see this second figure. Now the first figure was in a general quadrilateral. The second figure I have written rhombus. We will eventually study what a rhombus is, but for the time being, let's assume that we don't know what a rhombus is. So in this figure we can see, so the opposite sides are, what are the pair of opposite sides? One pair of opposite sides is PQ and SR. The other pair of opposite sides is PS and QR. Now you see visually in the diagram, it is indicated that when the sides PQ and SR are extended, they are not meeting, they are not intersecting at any point. So clearly we can see PQ is parallel to SR. Similarly, when the other two opposite sides, that is QR and PS, is extended, they are also not meeting at any point. So we can say that PS is parallel to QR. Now to indicate, there is a convention how to indicate that two lines are parallel. So PQ is parallel to SR. So we to visually indicate that PQ is parallel to SR, we put a arrow mark on PQ and SR. The arrow mark should be in the same direction. So this means that PQ is parallel to SR. Okay, so we see that one pair of so the pair of opposite sides PQ and SR, they are parallel to each other. Similarly, from the visual integration, we can also say that PS is parallel to QR. PS is parallel, sorry, not PS. We have already considered PS is parallel to QR. The other two opposite sides are PQ. We can see PQ is also parallel to, oh sorry, I'm messing it up. I wrote PS parallel to QR and I visually indicated incorrectly. So PS is parallel to QR means PS is this PS is parallel to QR. Okay, now we also see that we will also, from the visual indication, we can also say that PQ is parallel to SR, since when they are extended, when PQ and SR are extended, they are not intersecting at any point. So PQ is parallel to SR. So we can say that you can point the arrow direction in any direction. It does not matter. So let's say I can say PQ is parallel to SR. Now just like in to indicate the equality of sides and angles, you use one stroke, double stroke, and three strokes. Similarly, to indicate that two lines, to indicate the different parallelity. I mean, I don't know whether that is a word or not. So PS is parallel to QR. So we have indicated that using a single stroke parallel lines, parallel symbol. Now to indicate that PQ is parallel to SR, we need to use a double stroke, a different stroke of parallel symbol. So now this is fine. So PQ is parallel to SR. So we can see that both the pair of opposite sides in this quadrilateral figure, in this quadrilateral, are parallel, and hence this is a parallelogram. Actually, this is a rhombus, but anyway, we will discuss rhombus in some future video. So this is a parallelogram. Okay, let's see the figure 3. Inside the figure, I have actually written what kind of figure is this. This is actually a trapezium, but let's not focus what type of actual figure or diagram it is. Okay, so figure 3, we can clearly see. So what are the pair of opposite sides? The pair of opposite sides are WX. One pair of opposite sides are WX and ZY, and the other pair of opposite sides is WZ and XY. Now clearly from the visual indication of the dotted lines, we see that WZ and XY, when extended, they are intersecting at a point. Let's say this point be O. So definitely we can say WZ is not parallel to XY. So clearly one pair of opposite sides are not parallel. So immediately we can say this is not a parallelogram, because in a parallelogram both the pair of opposite sides must be parallel to each other. Even though in this figure it is by visual indication we see that WX is parallel to ZY, because when WX and ZY they are extended, they are not meeting at any point. So even though WX is parallel to ZY, so WX is parallel to ZY, so we can indicate that visually in the diagram as like this. But still this is not a parallelogram, because one pair of opposite sides is not parallel, that is WZ is not parallel to XY. So so this is not a parallelogram. Okay, let's see the third figure, which is basically a square. So from the visual indication, okay, so what are the opposite sides? What are the two pair of opposite sides? One pair of opposite sides is AD and BC. The other pair of opposite sides is AB and TC. Now clearly from the dotted lines we can see that the sides AB and DC, when extended, they are not meeting at any point. Okay, so we can see that AB is parallel to DC. So visually the fact that AB is parallel to DC, visually that can be indicated in the figure as like this. Okay, now we need to check whether the other pair of opposite sides are parallel or not. Okay, the other pair of parallel lines, the other pair of opposite sides is AD and BC. Clearly from the dotted lines we can also see that when AD and BC are extended, they are not meeting at intersecting at any point. So AD is also parallel to BC. What I am doing, I have already said that AB is parallel. I am discussing one opposite sides, and I am visually indicating at some other opposite sides. Okay, I need to be careful and focused. Okay, so AB. So clearly we know that AB is parallel to DC, because when these two are AB and DC are pair of opposite sides, and when they are extended in the diagram we can see they are not intersecting, so they are parallel. So when AB parallel to DC can be indicated visually like this. Okay, now let's see the sides AD and BC. Clearly, also as per the dotted lines, we see when the sides AD and BC are extended, they are also not intersecting at any point. So AD is also parallel to BC. So we can say AD is also parallel to BC. So clearly we can say that we can see that both the opposite pair of sides are parallel to each other. So this is a parallelogram. Okay. The next figure is basically a rectangle. Let's see. So in this figure, let me move the other figure to the right side a little bit. Okay. So in this figure, what are the opposite sides? The opposite sides in the figure 4 are PQ. One pair of opposite sides is PQ and SR. The other pair of opposite sides is PS and QR. Now clearly from the dotted lines we can see that when the pair of opposite sides PQ and SR are extended, they are not meeting at any point. So they are parallel. So we see that PQ is parallel to SR, which means that we can visually indicate that PQ is parallel to SR. Okay. Similarly, we see that when the pair of other opposite sides PS and QR, they are extended, they are not also intersecting at any point. So it is clear from the figure that PS is also parallel to QR. So PS is parallel to QR. So definitely we see that both the pair of opposite sides are parallel in this figure. So definitely this is a parallelogram. Okay. Figure 5. The opposite sides, this is a kite. So the opposite sides are AB and DC, and the other pair of opposite sides is BC and AD. Now let's see whether AB is parallel to DC or not, because AB and DC are one pair of opposite sides. Now clearly we see that when AB and DC are extended, they are intersecting at the point X. So definitely AB is not parallel to DC. So immediately at this point we can say this is not a parallelogram, because one pair of opposite sides is not parallel. Now the other pair of opposite sides is BC sorry, and AD. Visually, as per the visual indication, we can see that the sides BC and AD when extended are intersecting at the point Y, which clearly says that BC and AD are not parallel. So definitely in this figure, both the pair of opposite sides are not parallel to each other. So this is definitely not a parallelogram. Okay, let's see the final figure, that is 6, this figure. Now this figure is quite similar to figure number 2 that I discussed anyway. So the opposite sides are AB. One pair of opposite sides is AB and DC. The other pair of opposite sides are AD and BC. Let's see whether AB is parallel to DC or not. As per the indication, we can see indication of the dotted lines, we can see that the sides AB and DC when extended, they are not meeting at any point. So they are parallel to each other. So AB is parallel to DC. Okay, let's see the other pair of opposite sides, that is AD and BC. As per the visual indication, we can also see that when the sides AD and BC are extended, they are also not intersecting at any point. So AD is also parallel to BC. So AD is also parallel to BC. So clearly we see that both the pair of opposite sides are parallel, and hence this is a parallelogram. So this was a very basic and simple illustration with figures to understand whether a given figure is a parallelogram or not, based on the fact that whether the opposite pair of sides are parallel or not. So, what is a parallelogram? A parallelogram is a quadrilateral whose both pair of opposite sides are parallel. Okay. Now, some properties of parallelogram. Given a parallelogram, what can we say about its sides, diagonals, and angles, like the adjacent sides, pair of opposite angles, pair of adjacent angles, the diagonals? What can we say about them? So this is all about the properties of a parallelogram. Now, I have listed down 5 properties. I hope this will cover up all the properties. But in any other textbook, there could be more or less number of properties. If it is so, if you find any other well-defined properties of a parallelogram that I have that probably I will miss in this video, please let me know in the comment section. I will highly appreciate that. So I will discuss the properties or these 5 properties with reference to the 2 parallelograms that I have drawn. That is parallelogram number 1 on the left and parallelogram number 2 on the right. Okay. So the first property says that both pair of opposite sides are equal. In a parallelogram, both pair of opposite sides are equal. So what can be, so with reference to both the parallelograms, I will mathematically write some equation or result to illustrate each of these properties. Okay. So for the first parallelogram, it says that both pair of opposite sides are equal, which means that AB must be equal to DC and AD must be equal to BC. So because AB and DC, AB must be equal to DC and AD must be equal to BC, because AB and DC are one pair of opposite sides and AD and BC are other pair of opposite sides. So the 2 pairs of opposite sides must be equal. So this is for the diagram 1. So for the diagram 2, this will be PQ should be equal to SR and PS should be equal to QR. Okay. Property number 2 is both pair of opposite angles are equal. Both pair of opposite angles are equal. Okay. So for the parallelogram figure number 1, one pair of opposite angles is A and C. So they must be equal. They must be equals. And the other pair of opposite angles are B and D. So they must be equal. So for the diagram 1, we have angle A is equal to angle C and angle B is equal to angle D. The same thing for the figure 2 will be okay. So I did not visually indicated the property of 1 in figure 2. So we will have this side PS and QR will be equal and PQ and SR will be equal. Okay. So now regarding the property 2, the pair of opposite angles are equal. For figure 2, we have the angle P should be equal to angle R because they are pair of opposite angles, and angle Q should be equal to angle S because Q and S are the other pair of opposite angles. So we must have angle P is equal to angle R and angle Q is equal to angle S. The third property says diagonals bisect each other. We know that in a quadrilateral we have 2 diagonals. So similarly in a parallelogram also we will have 2 diagonals. So for the figure 1, it says that the diagonals bisect each other. Let's draw the 2 diagonals of the figure 1. So AC will be one diagonal because A and C are the pair of opposite vertices. We know that a diagonal in a quadrilateral is the line segment that joins a pair of 2 opposite vertices. Similarly, DB or BD is the other diagonal. Now let's show they are intersecting at the point, let's say let's say M. Let's say M. So what it means that diagonals bisect each other means that bisect each other means we can see that the diagonal AC is being bisected at the point M. So for figure 1, the diagonal AC has been bisected at the point M, which means that M is the midpoint of both the diagonals. M is the point at which both the diagonals intersect. And what does it mean that diagonals bisect each other? It means that the point of intersection of the two diagonals, that point will be the midpoint of both the diagonals. So we can say AM should be equal to MC, and we have also DM is equal to MB. Okay. Similarly, for the figure 2, let's draw the diagonal. The one diagonal will be joining the pair of opposite vertices Q and S. Q and S. The other diagonal will be joining the other pair of opposite vertices, that is P and R. P and R. Let's say they meet at the point N. They intersect at the point N. So we must have, so N must be the midpoint of the diagonal PR as well as QS. So we must have PN equals to NR and NS must be equal to QN. Okay. The fourth property says sum of each pair of adjacent angles is 180 degree. Okay. So we know that in a quadrilateral there are 4 pairs of adjacent angles. 4 pairs of adjacent angles. So for the figure 1, A and B is one pair of adjacent angles. A and B is one pair of adjacent angles. So we must have angle A plus angle B is equal to 180 degree. Now the why it is so, the proof I will discuss in some future video. Also we will have B and C, angle B and C is another pair of adjacent angles. So we must have angle B plus angle C is equal to 180 degree. Also angle C and D is a pair of adjacent angles. So we must have angle C plus angle D is equal to 180 degree. And finally angle D and A, they are also a pair of adjacent angles and their sum should be equal to 180 degree. So in a parallelogram, the sum of every pair of adjacent angles is equal to 180 degree. Okay. So this was for figure 1. For figure 2, we will have P and Q is one pair of adjacent angles. So angle P plus angle Q should be equal to 180 degree. Similarly, angle Q and R, they are another pair of adjacent angles. Their sum should be equal to 180 degree. Similarly, angle S and R is other pair of adjacent angles. Their sum should be equal to 180 degree. And finally, angle S and angle P, their sum should be equal to 180 degree. Okay. The last property is that each diagonals divide the parallelogram into two congruent triangles. So if you consider one diagonal in a parallelogram, it will divide the parallelogram into two triangles and they are congruent. So we can have for the figure 1, if I consider the diagonal AC, if I consider the diagonal AC, this is producing by arrow mark, I mean that it is producing or the creating, it is dividing the parallelogram into two triangles. The triangles are ADC, and you can say ABC, triangle ABC, and they are congruent. They are congruent. The proof of this I will do in some future video. So this is for the diagonal AC. The diagonal AC is dividing the parallelogram of figure 1 into two triangles, triangle ADC and triangle ABC, and they are congruent to each other. Similarly, if I consider the other diagonal, that is BD, other diagonal BD, this is creating the triangle ABD, two triangles, or you can say the diagonal BD is dividing the whole parallelogram into two triangles. One triangle is ABD and the other is BDC, and they are also congruent. They will be congruent. Okay, so this was for figure 1. Let's see for figure of the parallelogram 2. The diagonal QS is creating the two triangles QRS and the triangle PQS, and they will be congruent to each other. Similarly, if I consider the diagonal PR, it is creating the two triangle PQR and the triangle PSR, and they are congruent. So these are the 5 properties. I think this will cover up all the major properties of a parallelogram. There could be some more properties that can be derived from these properties. I will see if I can incorporate any more properties of a parallelogram. It is super important that you must understand and remember all the properties, major properties of a parallelogram, because and the proof of these properties and the proof of many of these properties will be heavily based on the congruency of triangles. So your concept about congruency of triangles, and in general the properties of triangles and the properties of parallel lines and angles, must be very clear to understand the proof of these properties. Okay, so the next video will be I will try to prove these properties using the concept of congruency of triangles, and will possibly, I don't know whether I can, if possibly I will try to do a few problems, geometrical problems based on the properties of parallelogram, and then I will start discussing the properties of individual special types of parallelograms or quadrilaterals. That is, I will talk about the square, rhombus, rectangle, kite, trapezium. So I hope this video will be beneficial to you for understanding the basic geometrical concept and properties of a parallelogram. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.